Hi Dennis, how are you?
Good morning, Katerina. Doing well. How about you?
Good, thank you. Should we wait a little bit or not sure?
Yeah, I say maybe we can wait a minute or two.
Okay.
I'm going to share the room in the meantime. And encourage others to do so as well if you would like. You can do that by hitting the square with arrow symbol on the bottom.
Pull up.
Welcome, BA, Dr. Rayerson, Neil, Ken, Joran, if I'm saying that right, and Sinem. Thanks for joining us. We'll be getting started shortly.
Okay, I think we can slowly start and
Yeah,
then.
let's go.
So on Monday we had Dr. Spontak here, and you can see the paper here in the link. And Dr. Richard Spontak, he's a distinguished professor of chemical and biomolecular engineering at the North Carolina State University. And he's a really amazing, not just amazing scientist that won many awards, but also amazing teacher. And he won also awards for being really involved in teaching and caring about his students personally. Especially during COVID, he is known for making a lot of effort to check on the students, how they are doing, and trying to have still kind of a community feeling. So I think that's quite amazing that he's not just an outstanding researcher, but also a really great person. And he talked about his research. His paper's title is An Integrated Materials Approach to Ultra-Permeable and Ultra-Selective CO2 Polymer Membranes. This advancement in technology will make it's basically the ground for having increased CO2 permeability and also CO2 selectivity, which increases basically for carbon capture by the technology by more than 150 fold of this materials to being able to capture carbon. And he didn't just make the conceptual experiments like as a model. He also showed the characteristics, the topological characteristics of his amine modified PDMS and PTFE membranes in experiments, and you can check out all the details of his of the membranes he created and the performance of these membranes in the paper, especially figure 3 and 4. And in the supplementary file that I merged here, you can also check out a more detailed description of how the experiment was set up and how they looked at the FTIR and ATIR spectra from the membranes, if you want to have way more detailed information, high resolution information about these membranes. And figure S5 from the supplementary PDF shows the experiment setup in pictures. It's quite impressive, I think, to look at it and to get a feel for it, how complex this is. But to basically summarize, he really achieved a quite outstanding increase in carbon capture with these membranes they created, and they will also be very, practically implementable. So, which is really good. So it's not just the stage of a model; it's really the stage of they made these membranes, they analyzed them and to a lot of detail in a lot of detail, and it's ready to go basically. So I thought that was very impressive.
It would be really interesting to know if he has ever collaborated with. We had another speaker, I forget his name right now, also working on CO2 permeability in membranes. Do you recall the name? It wasn't yesterday. I think it was the day before.
Oh, Dr. Singh. Yeah, he also collaborates with companies to actually do that. Yeah.
150x. That's impressive.
Yeah, it is. It's amazing. And he's such a great and nice guy also. So it's it's the perfect combination. And yeah, if anyone has any questions about what we are discussing, please raise your hand or write in the room chat with questions, or if you want me to share the files. But yeah, with these, if you click on the link, I think you can just download the PDF here. So if you would like to. And we can move on to the next guest speaker, who was Dr. Finger, and he is a surgeon and researcher. He's a MD, PhD, and he, as a surgeon, he works mostly on transplants, and he he did his master's at Harvard Medical School and in his residency at the Massachusetts General Hospital in Boston. And now he's a associate professor. And he mostly does transplants of kidney, liver, and pancreas islet transplantation to cure diabetes. And a big problem is in the field is to basically have these islands, this pancreatic islands, survive for a while until you can transplant them. And this paper here, and also his presentation. If you look at the presentation, it's yeah, he explains really well why it is so important to focus on tissue preservation because these pancreatic isolates, they are really not, yeah, they're really sensitive to temperature fluctuation. And he and his lab members, they found a way to develop a protocol that will make these pancreatic isolates viable, even if you would freeze them to preserve them for a while. And they describe here the cryoprotective agent cocktail they came up with, which is really interesting. And so you can check this out. And then he shows in the figures that adding the specific compounds, especially DMSO and sucrose and EG, decrease basically these ice crystals that would form and perforate the membranes of these cells. And and also another important part of the protocol was to have a really rapid cooling, and then to have a specific rewarming rate at and you can check that out in the figures. Yeah, they then analyzed in very different ways how these isolates would perform after this freezing and rewarming. And they looked at cell-specific viability and functionality, and compared these different protocols, and came up with a protocol that is really ideal for the recovery of these isolates. And this will enable really on a larger scale for people to receive these pancreatic isolates to basically cure diabetes. So that's quite impressive. And he's also collaborating with other labs that are working on creating pancreatic isolates from adult stem cells to in the future, so that in the future patients don't have to take any immune suppressant drugs after this transplant. So yeah, they're actively working on that. Apparently they have a lot of funding because they were very, very successful. And yeah, Jamie, go ahead.
Yeah, I was just going to say, did he mention at all when this is actually going to be rolled out for people to start making immunities to or curing diabetes all over the place? Did he give a timeline?
Well, it is very expensive. He's already doing that to do these transplants for people. It's just very expensive right now, and it's probably not on a large scale yet. And you have to have also a surgeon that's very well trained on this and uses the protocol. So yeah, hopefully more surgeons will start using this, but he is already using this.
And can it be used on anybody with type 1 or type 2 diabetes, or is this a preventative
No,
thing?
no, it's not preventative. It's to cure diabetes.
Right. So
Mhm.
if you've got a level 2 diabetes, he's been working on this. Yes.
Yeah.
I also remember him actually saying he started working on the pancreas. Was it the pancreas because he was looking at simpler organs to work on about transplanting, wasn't he? Because he started off by talking about looking at the leg, and he was like, "That's way too complicated. Let's start with something simple." And he went to the kidney, didn't he? Because it was simple connection to the rest of the body, and that had him talking about all of the work he was doing about keeping the cells like able to transplant and everything. It was really quite a fascinating talk.
Yeah, yeah, he was supposed to collaborate with military people to transplant like whole body parts, but Yeah, that's relatively controversial because you really need to be on really very strong anti like immune suppressants, and you have artificial legs that can do that, and you don't risk your life over time with being on these drugs. So yeah, but for late stage diabetes, where you have really people then dying of legs that, tissue that is dying off with age, this is really a trade that people would make, because people after years get blind, they lose limbs and so on due to diabetes. So having this option is really a really great way of extending life and preventing these issues.
It was really
Absolutely
interesting to
wonderful
hear him.
breakthrough to hear about it. Yeah, Dennis, go.
Sorry, it was really interesting to hear him describe all of the physiology and the mechanics of the process. I had never heard anything like that before, so that was really interesting to me.
Okay, then let me go to the next talk we had, and that was on Friday. Dr. Singh. Just get his paper. There it is. Okay, so he is at the University of Illinois, and he's really also a quite amazing and accomplished physicist and engineer. So he's in the division of material science and engineering at the oh, wait a second. I think, yeah. So and he is working on also on artificial photosynthetic systems for integrated carbon capture and conversion. And he achieved also, not just in the model, but also in real experiments, quite amazing way of carbon capture that you could use in all kinds of different settings, even at the scale of a home humidifier, basically. And it was quite affordable and at the acceptable rate of CO2 carbon capture. And yeah, I was really impressed with his work, and he also created a company and is working on scaling this technology to use this in different settings, at specific extreme climates, to use this for huge buildings, to basically renew the to capture the carbon of like where huge crowds are assembling, and instead of using an AC, basically use this technology, and yeah, for big scales where big companies would basically use this. So I think it was really cool because it's a really affordable scale and technology that is not really out of reach anymore. We could implement that rather sooner than later, and I really like that. And he's collaborating also with his colleague that they won the prize for from Elon Musk's initiative. I forgot what the name was, something with X, for carbon capture. So yeah, it's really exciting. I'm really yeah, this makes me really hopeful. Work like this, work like his and his colleagues, to achieve carbon capture in the next few years in a way that makes sense, basically.
And when he's using this in buildings, is this going to be something that's going to be coated like in the walls or on the surface, or how's that? I was wondering how's that going to work? Is it going to be like you walk into a building and it's got nice clean air now because all the humans breathing out the CO2, this would be filtering it out and just cleaning the place up?
So he explained that it's kind of would be a size of a bookshelf that would be, instead of basically an AC. Um, I don't know if you know how big buildings have their ACs built. So I would assume, like he talked about the size, where exactly would be in the building, but I would assume that it's at the same spot. Buildings now have the ACs on top, these huge buildings, and there it would like basically perform, instead of having these ACs that run on energy, but they just, they cool down the air but don't capture the carbon and take it out of the air. um, yeah, that these devices would be there instead of using a standard AC.
That is going to be amazing. I bet we're going to find like health of the people in the building just starting to improve in various ways. This is the kind of thing that seems really small and unimportant, but it's actually quite big. Everyone should check that one out for sure.
Yeah, he has amazing work and he's studying amazing collaborations with this technology, so I agree this will be yeah, very helpful, especially for extreme climates. He said where he's from, it's getting really hot in Pakistan and India, and the air quality is really low. So having these devices running, ideally on renewable energy, would be really, a huge step. Um, and then also in extreme cold climates, that would also make a lot of sense. Where you kind of have to regulate the air temperature and quality. Um, yeah, it would make a lot of sense in those buildings. Yeah.
The really interesting things to me were one, his when we were going through his personal journey, it started off as his father was a superintendent at an oil refinery in India, and it's very typical for people to continue the family business. So it was very exciting to see him progress forward rather than staying in hydrocarbons, moving to renewables, and working on carbon capture. The the facility that they're going to be building in South Chicago, or I believe is in progress, it's supposed to be um, operational sometime this year. They're looking at capturing 75 kilograms per hour of CO2, and those rates are really interesting. The other really interesting thing is that ideally they're looking at, he had said that one adult expels 1 kilogram of CO2 per day, I believe it was. And with his units, they're able to move that to a net zero. So they're able to cancel out all of the exhalations from humans wherever these are deployed inside of a space. So that's definitely exciting.
Yep, I agree. So I really wish him all the funding and all the luck to continue with this, because I think it's really
Inside society, inside society, we don't wish them all the best. We wish them all the funding.
yes, exactly. All the funding and the least
with an,
bureaucracy.
with an emphasis on the fun.
Yes, fun, funding, and low bureaucracy hurdles. That's what we wish our speakers will have. And then yesterday we had a really amazing talk and room with Dr. Barak Shoshani. He is a theoretical physicist, and he gave an amazing talk yesterday, and he's at the Perimeter Institute for Theoretical Physics. He's a trained mathematician and computational physicist at the Brock University in St. Catharines in Ontario, Canada. And his work focuses on the nature of time, causality, and general relativity in quantum mechanics, as well as symbolic and high performance scientific computing. He published, a lot of work and received awards, and he was a really great speaker. He explained different theories related to faster than light travel and time travel. That is his passion and his work, and explained here a lot of basic science theories and how he and his students are trying to tackle and prove that faster than light travel would be possible, and also do the math for it, and not just in language, he said, but also in math. And it was quite an impressive talk that will hopefully advance our speed and traveling. He explained why it's so important in the future if you really want to expand to different planets and colonize the universe, basically. That without doing this, it would take generations after generations to get to places. And he said he personally would prefer to see the place himself, not just be a whole to spend a whole life, birth and death, on some sort of vehicle that is traveling. So and for that, his most impressive one was to basically create a bubble that can that is compressed and expanded to manipulate the compression and expansion of space-time. So you would basically not have any human like G-force impact on the human, so it would be completely safe. That was, for example, one thing that I thought was really great and impressive, and I said I want a bubble already right now. But yeah, Jamie, go ahead.
Yeah, this particular talk, it cannot be overstated how absolutely incredible it was. Anyone listening to this right now who can do it, stop listening to me right now and go and listen to the recording. It is so, so good. This is for the sci-fi aficionados and the science nerds alike. You can join together hand in hand. We have everything. It has wormholes. It has warp bubbles. It has time dilation. It has paradoxes. He covers all of these things. He only just brushes on the surface. He's got links to his YouTube videos where he's talking about it. He was given information on where they might go next with this. He was talking about all the potential that there could be for this. A lot of this, he's theoretically giving solid evidence that it might be possible, certain aspects of it. The only problem is we're really quite tied by our technology just now, and there's still a lot about the universe we are discovering. So still a lot to go, but so incredibly exciting. I cannot stress this enough. Listen to it, listen to it, listen to it.
That's the first time you said that like this. So yeah, I agree. It was a great room.
That was definitely very enthusiastic, and I agree with you. The really interesting thing to me, there were two interesting things to me. The time dilation discussion that seemed to be kind of novel to a lot of people, and it was very exciting to hear the excitement for that. And then I had asked what, theoretically, how much energy would be involved in creating this faster than light travel. And I think his answer was all of the energy that is contained in the planet of, I think it was Saturn, but some like some massive amount of energy. So we have to figure that little detail out first, but very exciting.
100%. And he was also bringing up, what was it called again? I keep thinking it was antimatter, but it wasn't antimatter he was talking about, was
Exotic
it? It
matter.
was
Yeah.
exotic matter. See, I mean, even when I'm plugging it with all of the things I think about, there were still things I was missing out. This is something everybody must read. You have no time to spare. You have to listen to it. Listen about time travel and exotic matter. Absolutely great.
And in some senses, exotic matter is potentially antimatter. Antimatter is this concept from Star Trek, but the idea is about negative states of matter. So you could sort of call it antimatter, but the official term is exotic matter.
Yeah, I didn't want to actually call it antimatter in case I got unless there was some kind of reason why they didn't actually use antimatter instead of exotic. Um, we didn't get the chance to ask him the specifics on that. There were so many other questions to ask. Also, did I mention to everyone listening? Listen to it, listen to it, listen to it. Okay, that's me.
Okay, I think that was our week. It was quite remarkable, and we will continue with a very remarkable room tomorrow at 1 p.m. EST. Dr. Federico Felici. He's in Switzerland at the Plasma Center, and he will talk about controlling plasma for nuclear fusion with deep learning. And I just met with him to talk about how it's going to go tomorrow. And he most likely, also the Google team that was working on this, will also be here. Yeah, he is a really very accomplished nuclear plasma physicist that works in nuclear fusion and control engineering. And as I said, he's at the Swiss Plasma Center, EPFL. And yeah, he will talk about his work tomorrow at 1 p.m. EST, and also inviting the Google team that was collaborating with him on this. And then we'll have in the evening Dr. Bolton. She will talk about her mental illness related research and how early life stress induces glia dysfunction, and how that works. Glia are basically being rediscovered. A lot of focus in the last decades in neuroscience was on neurons only, and glia were kind of largely ignored. And now we are discovering more and more details about how glia contribute and actively participate in in brain activity and also mental illnesses, how they are highly involved. And learning about this will hopefully bring us forward in understanding mental illnesses better and treating them better in the future. And then on Wednesday, we'll have Dr. Bolani. He will talk about gut bacteria, that are different gut bacteria and how they are associated with different. I'm sorry, I had a call coming in. I hope you did you hear that?
Yep, we heard you gut bacteria, an individual. Yep.
Different personality traits. And then on Thursday at 1 p.m. EST, we have a researcher from the UK, Dr. Gibeline, who will talk about mitochondria transplantation between living cells. That's really the key for rejuvenation if we can do that, because over time, the mitochondria are the energy house. Basically, they produce energy for us to live. And with aging, the performance and the mutation rates are really high in the mitochondria, and the performance goes down. And while producing ATP for us, there is basically more and more pollutants will be released over time, and free radical leak, and basically transplanting healthy mitochondria is one of the keys, that also Aubrey de Grey, a big person in rejuvenation research, pointed that out many times, and he achieved this. And yeah, this will open up, and also different disorders are hypothesized to be due to mitochondria that are not working at their best performance, with the least free radical release. So this will be really an amazing room. I'm really looking forward to it. And then we'll have on Thursday Dr. Ulyin coming, talking about biomolecule mixes and how they can communicate, interact, and adapt to the environment independently. And on Friday, we'll have a fun room, how dogs recognize dog and human emotions. And on Saturday, we have another technology room with Dr. Cheng, and she will tell us about how she used molecular orbital based machine learning to improve machine learning performance. Yeah, so it will be a really amazing week. I'm really looking forward to it. And thanks everyone for coming, and I'm looking forward to having you again here soon.
Thanks for joining us, everybody. And next week is going to be absolutely fantastic. Be sure to be here with as many rooms as you can. And we will see you again next week for a summary for those of you who are just a little bit too busy. But until then, take care, everyone.
Okay, yeah, thank you. Bye, everyone. I'll close the room in 3, 2, 1. Bye.